Hey guys, it's Mrs. D, and I just want to go over the last section with you for ionic compounds, and that is naming multi-cation ionic compounds. And this is probably the most difficult one, but if you've done well so far, you're going to be able to figure this out. So this is nomenclature series number 5. So first off, this is where the transition and intertransition metals come from. So remember how we talked about those valence electrons are so difficult to predict because it really just depends on what it actually bonds with. And so sometimes copper, for example, will be 1, and copper sometimes will be a charge of 2. So it just depends on what in the compound. So here's some just examples of what these look like. Written in the compound form, let me squeeze this. There you go. So you see the 2 on the hydroxide. So this first one, we have zinc and oxygen. The next one, we have copper. And look, there's a polyatomic in there. So you could have a polyatomic with the transition metal or just simply an anion with the transition metal. So we have cobalt with the sulfate ion, and we have copper with the hydroxide. So let's get into how to do this. Oops. Okay, first off, the Roman numerals. You've got to know your Roman numerals for this, and you just basically need to know Roman numerals 1 through 10. So it may have been a while because it may have been like third or fourth or fifth grade. But just I numbered them at the top, 1 through 10. Remember, V's are 5 and X's are 10. So if you have 4, you have like IV because it's 1 leading up to 5. If you have 6, then you have VI. Again, with 10, for 9, you have IX leading up to 10. So the biggest thing to worry about, I'm not worried about the Roman numerals because if you ask me the Roman numeral, I'll tell you. But Roman numerals indicate the charge on the metal, not the subscript. I can't explain that enough. You have to understand Roman numerals indicate the charge on the metal. So let's write the chemical formulas here. First off, we have copper 2 chloride. So this is actually the easy part. Typically in the past, the chemical formula was the more difficult part, and this is actually the easiest part. So we write actually copper, and then we see chloride, and we see that "ide" comes from just the Cl. And we look at the periodic table, and Cl has a -1 charge. And in this case, we look at the Roman numeral, and copper has a 2+ charge. So then we're just going to crisscross like we have been doing. And so we bring those numbers down so we get our 1 over here so we don't write anything, and we write our Cl with a subscript of 2. This is copper 2 chloride. If I have cobalt 3 nitrate, so I have cobalt, so I write the sign for cobalt. Notice I see 8. So I'm going to have to look at my chart for the polyatomic ion, and 8 is NO3, and it has a -1 charge. Cobalt here, looking at the Roman numeral, has a +3 charge. So again, I'm going to crisscross, but notice again, when I crisscross, I want to bring that 3 to the outside of my parentheses for NO3. So I have cobalt, and I don't have just anything for cobalt because it's just assumed 1. So then I have NO3, and I want to put my parentheses and put a 3 on the outside. That means I have 3 total nitrates there. The last one I have lead, and even though lead on the periodic table doesn't look like it's a transition metal, lead and tin very much act like transition metals in this regard. And lead has a +4 charge from the Roman numeral IV. And then we see carbon 8, so we must know, hey, that's a polyatomic, and carbon 8's a 2-. So when we crisscross, we're going to bring that 4 to the outside and bring the 2 here. So we have Pb2CO3 4. Now here's the interesting part, and this is kind of hard, and I want you to pay attention. But you see the 2 here and the 4 here, that's not in the lowest terms because they're both multiples of 2. So we're going to write that as Pb and then carbonate CO3 with a 2 on the outside. This is the reduced version here. Now you try. So pause the video and give it a try. And now let me go through them with you here. So we have nickel 3 phosphide. So we have Ni, and the charge is a 3. And phosphide, I see ide, so it's just phosphorus, and phosphorus is a 3-. So if I crisscross, I have Ni3, P3. And that reduces because they both are 3. So I have NIP, NiP. There's NIP. Iron 2 nitrate. So I have Fe. Fe has a 2 plus charge. Look at my 8 here. 8 is NO3. And I've got a 1 minus charge. So I'm going to crisscross here. Bring my 2 to the outside. And my 1 comes here. So I have Fe. And then NO3 with a 2 on the outside. And finally, silver 1 nitrate. You're not always going to see this 1 for silver because the only charge for silver is a +1. It does not have any other charges. And silver's like that, and zinc is like that for a +2. It's still fine to write the Roman numerals. That way you can just like have a standard and you can just go for it. But silver's Ag, and it always has a +1 charge. And you'll find that on the back of your periodic table. And NO3 is a 1 minus charge, so we crisscross. So basically we just write AgNO3, silver nitrate. Now here's the part where this is the little bit tougher part. We have to write the name from the chemical formula. And the hard part is we have to determine what the charge is on our transition metal. So if I have TiO, the first thing I think about is what do I know here? And I know the charge on oxygen is always a 2 minus charge, but I don't know the charge on titanium. So I have to think through this. If I have 1 oxygen at a 2 minus charge, then overall I'm going to have a 2 minus because 1 times 2 minus is -2. If I have 1 titanium, then I have to figure out how to get a +2 so I can neutralize these. So 1 times a +2 is going to be titanium. So therefore titanium's charge here is 2. So I write titanium, and I'm going to write 2, and as my Roman numeral, titanium and then oxide, because it's just an oxygen, so I'm going to use my binary rules for that. Now this one's a little bit different. I have MnCl7, good gracious. So Cl is a -1 charge. 7 times a -1 is a -7. I only have 1 manganese. So my manganese charge must be a +7, 1 times +7 to cancel that out. So that 7, if you look, you can kind of backwards crisscross. See how I kind of backwards crisscross there to determine that charge? And that is legit. There is such a thing as manganese 7, which manganese is funky. And I wanted to show you that funky so that you can see how that works. So that's chloride again, because it's just 1 element, Cl. Okay, the last one is tin oxide. So I know my charge on oxygen's at 2 minus, but I have 2 oxygens here. So I take 2 times a -2 and I get a -4 overall. If I have 1 tin, 1 times what's going to be a +4? Well, I'm going to have to multiply it by a +4. So then I would have tin 4 oxide. Again, the Roman numeral is the charge on the transition metal. Now you try, pause the video, give it a try, and come back and I'll help you. Okay, so we have gold and bromine. So we have gold, bromine. I know the charge on bromine is a -1 charge. 3 times a -1 is -3. I have 1 gold, so I must have a +3 charge. And also, look, if I backward crisscross, see where that came from? My 1 came from here, my 3 came from the charge on the gold. So I would write gold 3, because remember I always use the charge, bromide. The charge is my Roman numeral. This next one I have copper, so I have Cu, and I have OH, and it has a 2 minus. Now the full OH, the full polyatomic, has a minus charge. So 2 times a -1 is -2, and I only have 1 copper. So my copper must be a +2 charge in order to get that 2 over here on the hydroxide if I work backward. So I've got copper, 2, and OH is hydroxide. And that is, again, that's one that you can add on to your polyatomic number or your polyatomic atoms on the end of your periodic table. So we have nickel oxide. An oxide is a 2 minus charge. I think about what I know. 3 times a minus 2 is minus 6. 2 times a what equals a positive 6, and that's going to be a 3. And look, if I backward crisscross, I realize where that 2 came from, or I realize where that 3 came from. So I have nickel. What's my charge on nickel? I have nickel 3 oxide, and I am good to go. You guys, I'll help you through this, but just keep plugging away and keep making sure that your Roman numeral is your charge on your transition metal.